Okay. Hi everyone, I'm Philipp. Since the room is still filling up, maybe we can do some defragmentation. Maybe move a bit more to the middle. Like if you have space in the middle, more to the middle please, so everybody can kind of join in and just go have a seat. So yes, please some defragmentation. Thank you. Like I guess that's the best way to explain it to IT people. Even though that the times of like the good old defragmentation are over. But yeah, if you have space in the middle, just squeeze in a bit more and then we can accommodate everybody. Thanks. Okay, so let's talk about Elasticsearch and kind of the revolution, evolution, where we've come from, where we're going. And this will mostly be demo-driven, so I hope the demo gods are in favor today. Let's see. So let's start with the revolution. If you look at data stores, like there's this site which kind of compares all the different data stores which are out there and their popularity, DB engines. If you look at that right now, it looks something like this, and we're very to be in the top 10 by now. Elasticsearch just made the top 10 and we'll try to move up on. I'm always amazed like what other systems are in there, like Microsoft Access, really? But yeah, so these are kind of the most common data stores we have out there. And we've been improving a lot recently. And if you look at the categories where you have search engine, we're actually by now the #1 search engine. So that was kind of the revolution part, how we got there. So this is actually logarithmic scale, so it looks very close at the top, but since it's logarithmic, like the difference is pretty far actually. So we have Elasticsearch has kind of overtaken the search space. And how did we get there? So it's very dark, I cannot really see you, but just quick raise of hands. Who is using Elasticsearch? Kind of get some, okay, that looks like a good, very good. How did we get here? So I will not show you like too fancy demos because we have a booth out there and we'll show you all the fancy demos there. We'll like look a bit more behind the scenes, like into the kitchen, I would say. And kitchen is actually a good term for that because everything started off with some kitchen work. And yes, I'm also working kind of in the kitchen. I'm part of our infrastructure team, so internal tooling, but I always say, this is a Unix pipe in the middle. I kind of piped it out into developer advocacy. So I speak a lot of times at conference and try to demo the cool stuff that we have. We have more spaces on the other side as well, if you want to move on. Okay, so continuing with the kitchen. So everything started back in kind of the kitchen when Shai, who started Elasticsearch, his wife moved to London to become a chef. And since he's a good husband, he tried to help her. And the way he tried to help her was he wanted to write something to search all her recipes because she had loads of recipes. And then she wanted to search for the ingredients that she had. And kind of the original blog post is still up, and his blog was the Do the Bytes. And the first system which he implemented around search was not called Elasticsearch, but that was Compass 1. And then at some point he figured out it needs to be redone, and he re-implemented that as Compass 2. And then he re-implemented that again as Compass 3, but he didn't call it Compass 3 because 3 is the lucky number, and he named that Elasticsearch. So actually it's kind of the third implementation. And he realized over the time that it shouldn't be just for Java because that's what he targeted initially, but it should work for every programming language and that it should be as scalable as possible. And that were the goals, and that's how Elasticsearch got started. And you can see the logos changed a bit over time, like our Photoshop skills have improved since then a bit. But yeah, that was the initial Elasticsearch logo. And that was kind of how the revolution started. And if you ping Elasticsearch, that is what you get. And you see the tagline at the bottom has been always the same, you know, for search. And that is kind of the core business what we've been into. So yeah, for search. And if you wonder who is using that, I guess I don't have to explain who these three sites are, but behind the search box, you always get Elasticsearch doing the hard work for you. And then kind of search turned out to be a broader problem, and people used it for other stuff as well. So we then added Kibana for the visualization part and Logstash to parse and enrich data. And that formed the infamous ELK stack, or famous, infamous, whatever. So Elasticsearch, Logstash, Kibana, we even had a plushy ELK as a toy to give away. And that worked well. Only over time, it became, yeah, not powerful enough, but this is already what a lot of customers are using. So these are just 3 examples. We have Spanish customers in that area totally as well. That worked very well. The only thing at some point, Logstash was maybe too complex to put out on all your servers, and we added another component called beats. Problem is there is no B in elk, so we kind of had to rename the entire thing. And if you haven't heard of beats, because every now and then people come to us and ask like, what is this beat thing? It's like a lightweight agent or forwarder. It's written in Go, it collects your information, it just ships and forwards it. And we can then do the parsing in log/still. We store everything in Elasticsearch, and Kibana will visualize it for you. So that's all the same. It's just like elk doesn't work for that anymore. And marketing has been working very hard on kind of replacing that elk thing. And what are we calling it now? So at first we came up with this, that is the belk or the elk bee. You can see it is an elk because it has the horns, and it's also a bee because it has the bee body, so the belk or the elk bee. But then marketing realized this is not really scalable, and Elasticsearch is all about scalability. And even for marketing terms, we want them to be scalable. But what happens if we add another term later on? That wouldn't really scale, and we would need to rename everything again. So we kind of said, well, this is not a good idea. Let's not go with the bulk. And now we call it the Elastic Stack. And you will do marketing and general product management a big favor if you just call it the Elastic Stack. And that is super scalable, because whatever open source product we put into that will still be called the Elastic Stack. And you can see new logo. And that was kind of part of the revolution. So that's taking over for search, for logs, for analytics, for metrics, all these use cases. And now we're kind of more in the evolution phase. So it's kind of like you have something that is working, that is widely used, and now you need to refine it and make it better over time. So the first thing I want to talk about is strictness. Previously, it was even for us sometimes a bit annoying that you could pass bad parameters, and Elasticsearch would just ignore what it didn't know. So I'll open up the demo right away, because we can pretty much demo all the rest. So if you haven't seen it, that is Kibana. That is still version 5. We'll actually live migrate to 6 in this talk. So this is 5.6.4 running here. You see I have a Docker Compose setup. I have 3 nodes basically with Elasticsearch. One is kind of the primary node here that happened, and then we have 2 other nodes. So we have a 3-node cluster plus Kibana. It's just Docker Compose. You can copy that directly from the documentation. So that is all working well. And then we have here for the strictness, that is kind of the first example. Do you spot the problem? Probably not, because it's quite hard to see. So I have a typo in there, and in previous versions, we would just ignore anything that had a typo in it. And you would be confused why is that not working the way I wanted to. But now we've changed that, and if you run this, it will actually tell you, well, something went wrong here. I cannot parse that argument. And it will actually tell you, like, maybe you meant something else. It will tell you that this token sire, or whatever you called it, it doesn't know that. And actually what you maybe meant is tokenizer. So if you change your query to tokenizer, then it will totally recognize that. So let's try to fix the tokenizer. And if you run that, well, it's deprecated, but at least it works. Because, yeah, you would need to pass in another parameter at the end. So this is all working, and it will actually tell you what is failing. So we have this strictness approach. We have that added to a few things. So for example, we have that for parameters and configurations. If you pass in any configurations that we don't know, we'll just not start up and tell you. Or the other thing are the Bootstrap checks. Anybody got problems with Bootstrap checks yet? Because they will make sure that you have your cluster or your nodes in a good state, and the node will only start up if you will not have bad experiences afterwards. It's just like some initial pain to make you not fail badly later on. So we're enforcing that. If you're kind of in production mode where you build a cluster or where you can build a cluster, we will enforce those. The next thing are rolling upgrades. So let's try to actually live upgrade our cluster here. So for another example afterwards, I will just add these 3 documents. We'll get into those later on. I just need to add 3 documents that we can test another feature afterwards. We have added or changed those. So what I will now do is I will just replace my nodes. So it's plain Docker Compose. So I have my environment file. I basically say I want to switch that out from 5.6.4 to 6 now. And then basically what I do is I just tell it, kill the Elasticsearch 3 node and just replace it live. And we can actually use Kibana while this is running to see what it's doing, and hopefully, yes. So you can see, out of my 3 nodes, 2 are just left. Both have the version 5.6.4, And the third node is currently starting up and will join the cluster soon again. So you can refresh it a few times, and after some time, a new 6.0 node would pop up. Because what we had previously, that is kind of a big, very simple now, but that was a big change. Because in previous versions, whenever you did a major version upgrade, it was stop the world. It was basically take down your entire cluster, replace everything, and then start it up again. But we can actually keep running queries while we have this upgrade here. So you can see we can upgrade or read that document. We could even do a write. And by now, you see the third node has joined again. And now this node is actually a 6.0 node. So we have a mixed cluster now. So it's 5.6 plus 6. And it's just working as we go along. So without further ado, I will replace the second node as well. And once again, you can keep reading here. So you can keep reading that document. You can check, like, we have only the 2 nodes. That will be rotated. It will join us in like a few moments. Well, Java process needs to start, then it needs to find the cluster, then we'll need to join the cluster and sync with the cluster, and only then it's kind of being shown as part of the cluster again. So that worked. We have replaced that as well. And finally, we can replace the third cluster. Problem is, Kibana is connected to that cluster, so I cannot show you that in Kibana. I will need to copy that curl command and fall back to the command line for that. So what you see is, here we have just our 2 nodes. They're running. Kibana will actually kind of die right now because it cannot reach its Elasticsearch instance. So Kibana is always talking to one specific Elasticsearch instance. We could just have switched Kibana to another Elasticsearch instance as well, but I took kind of the easy route and just show you on the command line now. So if we keep running that, at some point you see, we have all 3 nodes back up. Now we're on 6.0, and now we can reload that page, and it should come up again. And it hopefully has kept our history and everything. So yeah, we are back in business. So we have migrated the Elasticsearch cluster. What we haven't migrated yet is Kibana. And there is one more very nice thing I should show you is we have a new migration helper. It will actually check your cluster and tell you what you need to do to change that. So it's called Upgrade Assistant. It's available in XPack Basic. So if you haven't checked out XPack, like those are generally the commercial extensions, but we have free ones, which you can get as well, and that is in the XPack Basic package. So in that Upgrade Assistant, first it will tell you to take a snapshot or a backup of your data, which I didn't do since it's only test data, but please do that in production. And then you can actually run a cluster check. And that cluster check shows me here one error, and it tells me the only thing I actually need to change in my cluster to finish that upgrade now here is basically the meta information about Kibana. So Kibana stored some information, and that format changed in that version, and we'll quickly try to upgrade that as well. That looks a bit scary. So what you need to do is you block writes to that index, then you add a few more configurations to that. So the details you can just plainly copy out of our documentation. It will actually tell you that it's doing that. And then you can re-index that document. So now we don't have a .kibana index anymore, but we will have a .kibana dash version number. So then we have that version number here. We just re-indexed that. You need to set an alias, and then you can actually upgrade Kibana, and you will get the new Kibana as well. So let's quickly do that. And this should replace my Kibana container as well. Then it needs to start up. Since this is Node, this might also take a few seconds. Then we can reload the page and see if it worked. So let's see. I'll just clear out the URL and try to reload. Might fail for like 1 or 2 tries because, yeah, Node needs some time to start up as well. So let's see. It has finished here. If you run the query from before, like, yeah, the cluster is up, so your application could still interact with that. It's just Kibana that kind of needs to come up now. So hopefully Kibana, don't disappoint me. But it's Node. I will always blame Node for that. So until that has come up, come on. Actually, you can see all of that live since we have a lot of information flushing down here. You can see Kibana is doing something. So it's trying to join a cluster, and it says it's currently in the state uninitialized. It should change to initialized in a second. And then we can load that. And yes, this is now Kibana 6. So it changed a bit. I always explain it like that. Kibana 3 was black, 4 was white, 5 was colorful, and 6 is blue. This is kind of the blue version. You see, we have still the same menu point you're expecting, and we'll switch back to the dev console and continue where we have left off. So we have upgraded that. One more nice feature that we have added that I can show you off now is we have a new flood stage watermark. So previously we had, if you were running low on disk space, at some point we would stop allocating new shards on an instance. At some later point, like that was 85% of used disk space. At 90%, we would actively try to migrate shards away. But if you had no other space in the cluster elsewhere, we would just still keep writing data. And at some point, you would hit the wall, and your cluster would fail in a terrible fashion. What we do now, we've added a new flood stage at 95% of the disk space. If you have reached that 95% limit, we'll stop writes. You can still read from your cluster, but you cannot write and potentially do very bad stuff with your data. So what I'm doing here is I'm just inserting one document in an index called myFlood, and we're just storing that, and I can check out the disk space. So here you have how much space I have available on my MacBook. I will just set those to incredibly high values. So I set that do not allocate new shards to 400 gigs of free disk space, migrate away at 350 gigs, and do not write anything on 300 gigs. And since this MacBook only has 250 gigs of disk in total, I will be totally in that high flood stage watermark. And you see, this might take up to 10 seconds to be written out. I hope this has passed now. We can read back our document. So this is working. But if I try to insert a new document, this should result in an error now. And luckily it does. So this is a feature. This is what you want. You don't want to write more data and potentially kind of destroy your cluster. You can still read, but you cannot write. And now I want to kind of tell it, well, don't care about the flood stages. I will reset them. Will take some time to reload again. And then I can try to write another document into that. Do you think that will succeed? Who thinks that will succeed? Yeah, unfortunately, no, it's not that easy. There's one more thing you need to do. You can try to write it out. It will still tell you there is an error. What you need to do is once an index has locked up on any node that has been affected by that high watermark, you will need to unlock that index. So you need to run myFlood, that is the index name, and the setting to actually unblock that index. Now we have done that, and now we can actually write into that again. So we could always read, but writes were kind of blocked, and now we've unblocked the writes, but you will not be able to destroy your cluster or kind of, yeah, hurt your data in any way. Okay, next up, another very nice feature, sequence numbers. So sequence numbers are actually most easily explained. I have that in an animated GIF, and everybody needs animated GIFs. I think that should be it. So what you have here is you write out the document into the primary shard, and then it's being replicated to 2 other replicas. And you see you have the local checkpoint and the global checkpoint, and we'll kind of check within your cluster who has written out what information, what has been propagated to all the other nodes. So basically, you're replicating your data, and every time you acknowledge something, it will be also like acknowledged back, and you will see this global checkpoint. So once the nodes have the replicated node or the replicated shards have acknowledged globally that they have written that, the global checkpoint kind of will be raised up. So you can see we are writing out more documents here. And now we're replicating that, but in exactly that moment, the primary shard is failing now. So you will kind of see it disappear. Primary shard failed. Now the term 2, the middle node is kind of the new primary. It has never seen the write 4, and it will actually tell the other node to throw away that data because that hasn't been properly replicated. So that replication check or the sequence numbers will make sure that your data is in a consistent state across your entire cluster, and will also allow other features to come in the future. So for example, we will, not sure about the exact version, but we will have a feature about cross-data center replication in the future based on that feature as well. And we can actually quickly demo that feature. It sounds pretty weird to demo sequence numbers because it's just a counter, but it's actually doable. So we're saying I create a single shard with a single replica, and we can actually check that out. So my data landed on the Elasticsearch 3 and 2 node. and 3 is my primary shard, and 2 is my replica shard. And now I will start inserting documents. I will just insert a couple. And you can see this is pretty much what you've had in 2. The only thing that is new is the sequence number and the primary term. These are the new sequence number features that we have added here. And every single operation is one sequence number here. So if I run an insert here and delete it afterwards, like even the delete is a new sequence number operation. So even the delete will increase that. And even if I have deleted the document and run the delete again, it will still increment that. So it will just keep track of all the nodes that I've had. And now we can actually say, I want to restart the node, and I will just, let's kill the replica node. So I will stop the replica node. I will just restart it right away afterwards. It's starting up again. Since it is not in the cluster and I've told that, that index that it can only be on the nodes 2 and 3, we will have an unassigned replica now. We can actually check that out. And you can see the replica is right now unassigned because there is no node onto which it can allocate that. And once that node has joined again, where it can be allocated, it will be replicated to the other node. So yes, the node is up again. You can see it has joined that. Both of them contain the same number of documents and the same data. So that is all good. Let's insert some more documents. And then we can actually kill the primary shard. Let's quickly kill the primary shard. So that was 3. So the primary shard will now need to move as well. Let's restart the primary shard. What? No service? Sorry? There is yes, thank you. This. Otherwise, that would be weird if my node had suddenly dropped out. Too many edits, yes. Okay, so now, if you check that out, you see it has started up again. If we add more documents, you will actually see the sequence counter has increased, or if I insert a new document, you see my primary term here is still the primary term 1, but if I kill the search nodes 3 and I need to stop it actually that it works. If you don't stop it, it will not fail over. It's very disappointing. And now I can start it. If we check that out now, you can see, okay, the replica is unassigned, but we switched actually to the second node for that then. And we can still insert documents now, even though the other node is not available. But at some later point, you will see that it has joined again. So at some point, that replica should join us again. And once that happens, you can even check out, did I replay any documents out of that transaction log? So all of these writes I have just done go into the transaction log and can then be replayed afterwards. Previously, we would have done a file-based migration where we just copied off the different segments of the shards. But you can see here, the last 3 documents I've inserted have been replayed from that trans log. So that makes recoveries of your clusters much quicker. Okay, and then the final thing is types. Multiple types per index are going away. And we have kind of an elaborate migration plan for that, which I can quickly show you, which looks something like this. Problem is, types were always kind of a lie. They were not really existent in Lucene, which was writing out the data, but just an Elasticsearch concept. So what we're doing is, or kind of first, why? First off, different data types don't really work in one single index. Sparse data was never a great fit for Elasticsearch, since the sparsity would still just add some more disk overhead. And the scoring was also kind of overlapping between different types, even though you probably didn't expect that. But the type was basically always a lie. So the only thing that you cared for was the index. So what are we doing? We are kind of disabling multiple types for new indices in 6. In 7, the type will be optional in the API, and in 8, everything will be gone around types. And this is the final demo, since we're, I'm sure, running low on time already, yes. So that is what I have done in version 5 still. So I have inserted into the types index, I have added the type 1, type 2, and type 3. And now I add a new index which has just been created in version 6, which is called notypes, the index. And we generally use the default type then for doc, and I've inserted that one document here which you've seen into notypes with the type doc. We have inserted that. Now if I try to insert into that index another type with a different type, which is called other, this will actually fail, and it will tell me you can only use a single type per index from now on. How can you migrate your old data? You can just do a reindex. Basically, you're saying, I take that old index, the types, copy it over to the notypes, use the, I set a new type, which I set the type always to doc, and the ID of the old document is just a combination of the type and the ID, so it will still be unique. And if I run that, you can copy over the data, and now I have migrated all my 4 documents. Okay, it's not an impressive number, but you get the idea. We have migrated everything to the no type version of that, so it's always in the index no types. The type is doc. We have the value, and for the old documents, I've also stored that previous type field, which was the underscore type, in another field called type, so you could still make the difference, and the ID is now the type and the ID, so it's guaranteed to be still unique. And that is how you migrate of multiple types. So we are trying to make that as painless or without pain as possible. So that is kind of how you can migrate. Okay. Yeah. I think let's skip to the conclusion since we're low on time. Okay. So we have seen quite some cool features. The one thing I skipped for time reasons is we will have in a future version in 6.1, we will have a smarter way to pick from which shard to query data, so either the primer or the replica. So we're continuously adding performance improvements as well. And otherwise, we've seen strictness to Elasticsearch in 5 already. We can do rolling upgrades from 5 to 6 now. Other versions, previous upgrades were always a stop the world upgrade. I've quickly demoed the flood stage where we'll just stop inserting data to not corrupt your data. We have the sequence numbers, which are both for correctness, better or speedier recovery, and new features like cross-data center replication. Types are going away. You can still enable multiple types per index right now, but you probably should not, because at some point you will need to make that switch. And you have also methods to move off that. With that, we're pretty much done. If you have any in-depth questions or want to see more demos or want to have, I don't know, a deeper discussion about anything, come to the booth. We also have all the swag there. I didn't carry over all the stickers. Just come to the booth for that. If there are any quick questions, now is your chance. Otherwise, at the booth. Thanks. And I would love to take a selfie with you, but I think it's too dark. It's very unfortunate. Questions? Yes, sure, shout. I will try to repeat.
When moving from multiple types to multiple indices, what if there were this parent-child mapping used before in the index? How do we mitigate that?
Yes, so the question was what happens to parent-child, because that was one of the use cases which required multiple types within one index. There is a new data type called, or a new field called join field. So that will live in one single index. You need to migrate that as well. You need to migrate that to the join index. So that is totally possible. The only limitation right now is you can have only a single parent-child relationship per index. Previously, you could have multiple ones, but right now you can only have one single parent-child relationship within one index, but you don't need different types anymore. But it is a very good question, because that was one of the main use cases of multiple types per document. There is a way around that, and it's a new join field. Yes, I hope that.
Can you point a documentation to the join field, or?
Yeah, I think it's the first hit. If you let me Google that. It should be pretty much Elasticsearch join field. So you have a new data type in. Let's go to the master documentation. But you have this new So you will need to provide an explicit mapping for that, but it will all live in a single document, and I'll make it slightly larger. So join data type, that is what you want. I hope
Thank
that answers
you.
the question. Sure, and I think we're out of time. If you have more questions, well, ask my colleagues or me at the booth. We're happy to help. Thanks a lot.